Everybody, how are we doing? The volume's not all the way up, but now it is. Wow, it might be too loud. I don't know. How's everyone doing? I think I can actually move the mic further away. A little chill music right here. Can I hear the chill music again? I think I can. Yes, I can. I'm out of frame though. What's up with that? What is up with that? Let me go and get my green screen self. Who's here? I'm gonna send out some announcements to see who's here. Camera green screened. So then I need to pan the camera down a little bit. Nima, good to see you. Good to see you here. I'm gonna pan the camera down just a tiny bit. Pan it down just a little bit. Oh, well, wow, I got gray hairs on my head. Man, what's happening? Gray hairs, no! Ah! Gray hairs. You see now, what have I done? Oh, I should never. Oh, there you go. See if I stand up straight. Points! I gotta wake up Mewbot. Waking up Mewbot. Mewbot, wake up. Mewbot, here. See, that's too low. You get it? Oh my gosh, what am I doing? Okay, wait. Okay. I think we've done it. I think we're back to where we always were. Because now I can reach up. Reach up, stay in frame. Mewbot is awake now. Sending out the announcements that it has started. It takes so long to send out an announcement. Some chapter 5. Mewbot is awake now. We'll throw you some points. Ma Pearson. Get in frame right here. What questions do people have? It is time for questions. Chapter 5, part 1. Sure, we've done. Do you want to do the homework or the quiz? We've done the homework fully. Just name a question. And we can do it. We've done the full homework during class, but we can do whatever people want right now. If you're here, you get to pick. Which one? Sure, ask away. Which one shall we do? People with Z scores are 2 point. And which is that a homework or quiz question? And how's it start? People with the Z score of 2.75 would be 2.75 standard deviations above the mean. So we go to the mean and add 2.75 standard deviations. Which one is that? Which one is that? It's the gene, and is it? Oh, the homework has the same pattern. So, which one is that on the homework? Question what on the homework? Like which number on the homework? I can find it here in a second. Replace questions 2. All right, let's go check it out. Question 2 on the homework. Okay, so here we are over to the mic screen. Okay, so notation is going to be key for this question. Let me go ahead and put a bookmark on it here. So 503, Stat 201, Chapter 5, Part 1, Homework, Question 2. Okay, so with this question, it's all about notation. And what do we mean by that? You should be able to notate everything within this question, and you should know some formulas. We'll go through the theory here in a second, but we're going to do the formula, and then we're going to do the theory. If you know how to solve these, beep, 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 beep. Oh man, made hard numbers on me today. Did I get it right? I did. But how did I do that? Let's check it out. You ready? Okay. So I'm going to highlight things. I want you to tell me what these things are. This is your practice. And to see how we can get these answers. What is this? What is this? What is this? So go ahead and tell me what these things are. I'll mark them when you say. This is your practice, especially if you're watching this in the future, to know what's in this problem. We get different numbers, and you should be able to mark what they all are, and then we're going to write down a formula which we can use to solve for the answer. Then I'll also tell you how I theoretically figured out the answer. So what do you think? I need to know what 2.75 is, what 100 is, what 24 is. You have to know what these things are. You have to know the notation. You have to know what they mean, and then you can use it to solve for the answer. So what do we have right here? What are these things? In notation. or words. You can say words, which you're basically then repeating back, and then we can practice the notation for them. Any one of these things right here. It's the mean is the center of the normal curve, and so we go right here, and this would be what we call mu. And then what else do we have? You're on the right track. Great job, Nima, right there. So it is the center of the curve. And so we'd put 100 right here. What else do we have? What else do we have? What else do we have here on the screen? The mean is the center of the normal curve, exactly. It's called mu. So what else do we have? This is really good practice. All the theory helps us solve other problems. You know how to solve this one. You can solve additional problems. You understand the theory for the test. The mean is the center of the normal curve. Z-scores. Great job, Clay, right there. We got a Z-score. A Z-score is from the formula that Z is equal to the mean plus the wait, a Z-score. I was thinking about an observation. Haha. Yeah, the Z-score is the observation minus the mean, and we'll do mean in the other format. The observation minus the mean over the standard deviation. So if you notice right here, we have a Z-score, we have a mean, and what else do we need now? Well, the Z-score is how much things are away in terms of standard deviations, and we're missing one last thing right here that's highlighted. We're missing one last thing. What is the last thing we're missing? The standard deviation, exactly. And the standard deviation is what in notation? Good answers, keep them coming. The standard deviation is what in notation? What is the standard deviation in notation? Once again, if you do these steps and you practice, you remember more to it, and great job. And then in notation, it'd be sigma. So that's sigma right there. And what do you notice? We actually have everything here in notation except for the observation, which it wants us to find. We can put the z-scores down below here, like a z-score of 0, 1, 2, and 3, -1, -2, and -3. We can go up by units of the standard deviation. If there was a z-score of 1, then what would its observation be? At a z-score of 1, what would the observation be? So try to figure that out right here. At a z-score of 1, test not tomorrow, test a week from tomorrow. Unless I'm going crazy. Test is a week from tomorrow, unless I'm going crazy. If I am, I'm still sorry, because I'm pretty sure it's weak. Good questions, Clay, right there. So at a z-score of 1, what would be the observation? At a z-score of 1, what would be the observation? Really good practice right here. This question is a quick solve, but let's know what we're doing on it. So at a z-score of 1, what's the observation? Because you're one standard deviation above the mean. Be careful, careful. What is the standard deviation? And then think you're going up that many units from 100. Good answers right there, Nima. And Clay has, does that make sense, Nima? What Clay's done right there is they've just added one standard deviation. Does that, and then, because this is a unit of 24, you're going up every time. And think we're looking for the y observation of around, I'll do a light purple right here. We're looking for right about here at 2.75 z-score. So that's where we're looking at, and we would land. So you can go up and do this and go to 148, and then you would add a 0.75 z-score. So you can rework this formula right here to solve for y, and you would get y equals, I'll disappear for a moment, y equals the mean plus the standard deviation times the z-score. And you can plug in your numbers that you would have the mean of 100 plus the standard deviation of 24 times the z-score of 2.75 is equal to 166. With 64%, you might be talking about the 68, 95, and 99.7 rule. 68, 95, 99.7 rule. So there would be 68% of data contained between 76 to 124. So that would be a fact. 68% of the data would be contained within that. You could do above and below, and those would be empirical rule questions. So there's a lot you can build off of this question. Nima, does this make sense right here? The formula you need to solve right here would be the observation is equal to the mean plus the standard deviation times the z-score. So that's going to be the formula right there. If you directly plug in the numbers, you can also draw the curve and you can see about where it is. You can tell it's somewhere between 148 and 172. So, because 172 is another standard deviation above. But doing these steps, writing it out like this is key. What question should we do next? We're doing some chapter 5 right now. Start chapter 5 early. Chapter 5 is a tough one. It takes practice. It takes work to understand it. You just don't want to be in the boat where you're doing chapter 5 the night it's due and you're like, I can't remember. We did this so long ago. We did it early because I want you to start it early, and then you get to practice it and ask questions, and you get to review it. It makes more sense. So what should we do now? Which you can pick any question. We could do more homework. We could do quiz questions. So if you're here, ask questions. What do you want to do? What do you want to do? What should we do? Office hours. I got all caught up on emails this weekend. Got behind, got all caught up. Oh, nice. Okay, good. Mike sent me pictures of what I need to look like for our interview. We're doing a session. I need hair and makeup for this session. I'll tell Mike that. What question shall we do? Pick another question. What are you wondering about? It is open office hours. It is open office hours. Pick what you want to do and we'll do it. Question 3. Let's do question 3 right here. Let me go away from this. Question 3. Okay. Mark it here in the notes. This one is wondering about z-scores too. What is the z-score formula? So go ahead and put the z-score formula in the chat for me as we're practicing. How would you describe the z-score formula? The more you say it, the more you repeat it, the better you get with it. So what is the z-score formula? Try to do it right now. If you're watching in the future, you should be able to write the z-score formula. We don't give it to you on the tests. One of the few formulas we don't give because it's so fundamental that you have to know what a z-score is. Who can tell me what a z-score formula is in the chat? What is the z-score formula? Anyone know? What is the formula for a z-score? Take a moment. Someone's probably fast forwarding right now. They're like, no. See if you know it. Write it on your sheet of paper. What is a z-score equal to? Z-score equals what? No, we got Clay and Nima here. We'll throw points. Right or wrong answers, you get points. It's good practice. Right or wrong answers, you get points either way. Give it a little more time. Don't worry about being wrong. Just put an answer out there in the world and see if you're right. Any idea what a z-score is equal to? Think about we were just drawing it out a moment ago, and you can kind of see it visually down here at the bottom. Yay! Great job. Yeah, that's it. Nice job, Nima. It is equal to the observation minus the mean over... The observation equals the mean. You can call the observation x if you want. Usually we call it y. Observation minus mean over standard deviation. So if you think about this, it's how far away is the observed value from the mean in terms of standard deviations. So what we have here is 2 tests. So what is the observed value of her economics score? What is the observed value of her math score? What is the mean for her math and standard deviation for her math, or economics rather? So let me ask you this. If I were to write y bar or y math, what is y math equal to? What is y sub math equal to? Look through everything written up here and find me where y math is, which is the observed mathematics score. That's what she made on math. What is y math equal to? Go ahead and try to find it in this output. What is y math equal to? Don't worry about being wrong. That is observed mathematics score. And make sure in your notes, write down y is the observed value. Y is the observation. Mu is the mean, the population mean. Sigma is the standard deviation. You should know all this. And Z is how many standard deviations something is above or below the mean. So what is y sub m right here? Find it above. Which number is y sub m? Which number is y sub m? Any thoughts? Which of those many numbers is y sub m? 87, that is correct. Great job, Nima, right there. 87 is correct. That's the observed mathematics score. And then we just take what the mean of the mathematics test was. And then we take the standard deviation for mathematics. And there's the standard deviation right there. And we go here and we do 87 minus 66 divided by 12 equals to 21 divided by 12, which is equal to 1.75. And that's the math. And then the English would be the same way. It's just going to be the numbers for English. So we would do sub E. It's just going to be the economic or the, it's economics. And then we go here and we mark the observed economics score, which observed for economics is this. Good. Just make sure I do the right ones. I've done this question wrong many a times because I look at the wrong ones, and the mean is here and the standard deviation is here. And then we plug in the values. This time we're going to go down here. And so we have 81 minus 72 over 7, which is equal to 9 over 7, which is going to be equal to 1.29. We'll double check, but that's 9/7, which is 1.29. And that's for economics. So she didn't score as high above in economics. She did better in math. She scored more standard deviations above in math. So 1.79, 1.75, 1.29. And so this is economics, 1.29 if I did my math right. And she was above the mean. And she scored 1.75 above the mean in math. And she did better on math. Did I do it all right? I did. Does that make sense, Nima, right there? So the key to this one especially is marking the notation. And we have observation minus mean over standard deviation. And then there's the difference. And then there is the z-score for math. I marked it M and E at the end. The subscript is just a notation to let us know which one I did, because I did just use the same formula, but do it for the mathematics version. So for those wondering at the end right here, we could do like a line right here and say like, whoa, sure, why not? And you could say that this is all the math stuff and this is all the economic stuff down there. So just kind of a clear, different pathway right there that we did math versus economics. What should we do now, Nima? Let us know. And this is good practice. This is just finding z-scores right here. So we also have empirical stuff, checking normality, other things within this chapter, but knowing the z-score formula, know what an observation is, know what a mean is, know what a standard deviation is. And I cannot state this enough that drawing it out is huge. We could have drawn this one out also and saw where they were at, and then found the z-score that way. So drawing it out is really what you need to do for all these problems. You really want to get the best practice. So try drawing it out. We did the formulas, but you can also draw this out and get really good help. Which question should we do next? Take your pick. Who's all here? You can do any question people want, any quiz question, any homework question, you name it. Who wants to do a question right here? Who wants to do a question? Questions, name the questions. I might do some if no one says any. Which one should we do? Name the questions, we shall do it. What questions shall we do? No one's saying any questions? No! Might do some of the hardest chapter 5 questions. Let's see, assignment manager. Chapter 5. Part 1 quiz. Okay, got a billion questions right here. You'll get stuck on this one. Do this one. Don't worry, jump in and ask more questions if you want. Okay. Okay. Company that manufactures rivets believes the shear strength in pounds is modeled by a normal with a mean of 650 and a standard deviation of 50. And with this information alone, you can kind of look at the graphics and tell that this one has the wrong standard deviation. It goes up by 25, so that's wrong. And this one right here is right. This one goes up by 5, so it's wrong. This one goes up by 100, so it's wrong. It has to be this one. Because what you're looking for is you're looking for the right mean and the right standard deviation. We'll take a quick screenshot of this and show that all you're looking for in this graphic is the mean needs to be at the center, and then the standard deviation is the units by which you go up and down each time. So that concurs right here that this is the right graphic, and we now know we have the right one. Would it be safe to use rivets of 600 pounds? Well, zooming in on this graphic, if you look at where 600 is at, you can use the empirical rule, which we do give you these numbers on the test, and we tell you which problems to solve with the empirical rule. And 600 pounds is right here. And if 68% is between here, that leaves 16% on either side. Why 16%? Well, because 68% between leaves 32 total. You subtract from 100, you do 100 minus 68 to get 32, and then you cut the 32 in half. So there'd be 32% total on the outside and 16%. So that means 16% of the rivets would have a shear strength of 600 or less. So that is kind of an issue if there's like 16% of the rivets we make don't have that shear strength. So no, because about 16% would have a shear strength of that. That means they could break. But what percent of rivets are expected to fall below 750? We're going to do the same sort of trick right here and draw the graphic again. So once again, we have to use the empirical rule numbers because the problem gives it to us. And we go right here on the graphic and we go to where 750 is at. Notice 750 is where 95 is at. So if 95 is on the inside, total on the outside is 2.5%. I mean, total is 5%. Half of that is 2.5 on either side. So total is 5% because 95% inside. Uh-oh. Don't tell me my camera. Oh, there's my camera. 95% inside, 5% outside, 2.5 on either side. And now you'll notice right here that it wants below. Well, we can do a trick because if 2.5% is above, 97.5% is below, because you would go through the 95% and through the 2.5%. And if you do a division right here, you should have that it adds up to 100%. Like above this point is 2.5, thus below this point is 97.5. And you can also tell because you go through and you do the whole ride the train tracks. We talk about like, woo, like you're gonna skateboard on this like Tony Hawk style across this thing and it's gonna go up to 100%. So make sure you're using those sorts of methods to confirm your answers that you've drawn this properly. And we do, for problems that ask you to use the 68, 95, 99.7 rule, we do give you those numbers. So make sure you know what you're doing with them as we're doing with this problem. So the percent below that would be 97.5. Now we get to one of the weirder questions that I sometimes get wrong on a 50-50 shot. So I'm going to second guess myself and pick the wrong one. It's either A or C. So they either want above or below the mean. Rivets are used in a variety of applications with varying shear strength requirements. What is the maximum shear strength for what you would feel comfortably approving this rivet? Explain your reasoning. So it says maximum, and that would mean above the mean. It just wants you to do 6 standard deviations above. So it's saying maximum. And they're really just asking you, what is 6 standard deviations above the mean? Unless I'm supposed to do the below, and I always get this one wrong. But it says maximum, which is a higher number. And how did I get that number? Let's check, see if we're right. No, it's below. I hate that. Darn you, problem. Every time. Tricking me. Really? Oh, we got something. Wait a minute. Slow down your brain. Slow down your brain. Okay. I see it. Does anyone know what I did wrong? I think it's still going to be above. But it was the mean. I thought the mean was 600. The mean was 650. And it is still below. It's one of those days. It's going to be 350 then. There we go. 4th try. There we go. What I did wrong the first time is I used the wrong mean. And it is below, even though it says maximum. So right here, you see the mean of 650 and the standard deviation of 50. So all we're basically asking you to do, this question would never be worded this way on a test. Never, ever, ever. Is we're saying go to the curve, 650 is at the center of the curve, and go down 6 standard deviations. Now you'd be going off the curve, and there are data points that go beyond the curve, but you'd go down to 450, then you go down to 400, and then you go down to 350. You can also do, to find the observation, you can do the observation equals the mean plus the z-score times the standard deviation, where 350 is going to be equal to the mean of 650 plus the z-score of -6 times the standard deviation of 50. And that is how we can find it. I just always find that one to be weirded it has weird wording to it. Worded weirdly. That's what I was trying to say. So never liked the way. And it always tricks me because I second guess myself. I'm like, I've gotten this one wrong. So then I'm like, it should be the above because it says this. And I should second guess my second guess because I was right the first time. Because it would make sense that you'd be worried about rivets that have a very low shear strength. So that makes more sense what you'd be worried about. And it should say that. It should say they're very worried about the shear strength being very low. What would this be for 6 standard deviations when we think about weak shear strength? Yeah, which one you want to do? Yeah, Jackie, ask a question related to that, and we can do it. Hop it on the main screen. Which question are you working on? I'll open up those questions. And I'll try not to get any wrong. Which one you working on? Chapter 5, Part 2. Name a question, we'll do it. I'll try and remember the right mean and standard deviation. Chapter 5, Part 2. Norm model IQs. I think I got that open right now. Let's go do it. So these questions right here, we'll put the timestamp in a second. These questions, you want to use the apps. Now you say, well, how would I do this on the test? On the test, we would show you pictures. Look at the Canvas content to know exactly what the test is going to look like. Not exactly, but the test will look a lot like Canvas content. So if you're wondering or fearful of how the test will look, Canvas content is your best bet. So this question wants us to use the normal model. And so what I'm going to do is I'm going to take some guesses. So how do we take guesses? Let's see how close our guesses are. See if we can get any right by guessing. What percent of people would have an IQ above 85? So I'm going to guess 82.8. What percent have an IQ below 95? Oof, come on. Really tough one on me right there. Below 95, 42.6. Between 116 and 128, I'm going to go 11.2. We got 0 correct. Now, how was I doing these? Well, I was using the empirical rule. And I'll show you visually what I was doing when we go here to the app. So when you go to the app to do these questions, you want to first enter in the what and the what. What's the first things you should enter in when using the applet? What's the first thing you should enter in when using the applet? When using the applet, you should first enter in what and what. What should you first enter in? I'm going to get these side by side right here. What should you first enter in when using the applet? You're using the applet. You should first enter in what and what. So take a look at the applet over here on the right side of the screen. And what should you enter in first? Any thoughts? So think about the normal model, the information it gives you, and think about what you should enter in. Oh, I bet someone knows. Feel free to answer. What should we enter in to the applet to begin? Take a guess at the values. Yep, well, exactly the mean. Great job, Jackie. The mean and the standard deviation. Boom. So now, after we enter in the mean and the standard deviation, it changes the numbers down below to the mean and the standard deviation. Now we need to ask, are we trying to find an area? So do we need to find x using a p-value, which will find a value on this curve, or do we want to find a percent? So do we want to find a percent using the values, or a value like an IQ using a percent? So what are we trying to find, a value or a percent? Are we trying to find a percent or a value? Think of x as a value. Which of those are we trying to find over here? A percent? Like, does it say solve for a percent, or does it say solve for an IQ? An IQ would be an x. An x is a value on the curve. It says solve for a percent, so we click right there. So now we've set it up properly. Make sure to do that. Put your mean and standard deviation in, and then make sure you're either solving for percentages or solving for the values on the curve. So now we have to say to ourselves, well, let's look at the curve. Notice right here, 85 is almost perfectly at a z-score of what? And I want to show you why I took this guess. 85 is almost perfectly at a z-score of what? So 85 is almost perfectly at a z-score of what? Where's 85 at on the curve? It's almost perfectly at a z-score of what? Because think about the standard deviation. 85, because we're doing over 85, is almost perfectly at a z-score of what? 85 is almost perfectly at a z-score of what? Look at where 84 is at. Think about where 85 is at. So think about the z-score, which is how many standard deviations below the mean is 85. Where is 85 almost at a z-score at? Well, be careful. And good answers, Jackie will tell you some points right here. So if you take observation, if we do 85 minus 100 over standard deviation, it's at a z-score of almost -1. Do you see how 84 right here, I'll zoom back in on it. Do you see how 84 is right there at a z-score of -1, and 85 would be right here? So 85 is going to be right about there at that many standard deviations below the mean, because it's not quite a full standard deviation. It's 5/16 of a standard deviation below the mean. Does that make sense visually? Because you want to know what the applet's going to do for you, to be like, oh, it's going to put a line right here at 85. If I say mark where 85 is at, and I can get the above percent right there. And that was, oh my gosh, you got to be kidding me. No way, I was that close. I think I was just one decimal off right here, and I would have got that one correct. Oh man, so close. So using the empirical rule, we've gotten one of these right. What I knew is below 84 is 16%. We'll round it here. Wait, what? Oh, that's doing that. I was going for the rounding. Below 84 is 16%, or 84. And if we go below it, we see the 16, and that's due to the 68 rule. Is this making sense, Jackie? I'm also covering empirical right now, but the key is you just put in the number right here of 85 and you do above, and it'll tell you the area above 85. But then also using the empirical rule, we can take some educated guesses to say, well, 16% of the data is below 84, so then 84% would be above 84, interestingly enough, and we can make some guesses right there at the area, knowing what the empirical rule shows. How about below 95? 95 is near the what of the curve. So what would you say 95 is near? 95 is near the what of the curve. Look at where 95 is at. So think about where 95 is at on this curve. 95 is near the what of this curve. 95 is near the what of this curve. 95 is near the what of this curve. What is 95 near on this curve? Any thoughts? We'll throw some points here, get everyone active. Well, what is 95 near? On this curve, 95 is very close to what? Kind of. This is the mean and the median. The center, the mean and median are in the same spot. And think about this. How much data is below 100? So how much, well, there's the answer. But confirm for me, how much data is below 100? How much data is below 100? Like seeing it here visually, what percent would be below 100? And we should confirm these answers. We should be seeing things like, oh yeah, that makes sense. If that's the mean of the curve, how much data is below 100? Because it's the mean of the curve. Half the data. So doesn't it make sense that 95, because we'd be moving downward, would have less than that? And look right here, it's 38%. So I was pretty off on this guess. That's a much harder one. You might remember I was like, oh gosh. I was like, that's a tough one. So now we have two answers correct. And we can see here visually, 37.7% of the data is below 95. It even says right here, below 95. And we can confirm with what it says right here, below 95, 37.7% of the data. So what button do you think I'm going to click now, Jackie? What do you think I should do to do IQs between these numbers? What do you think I should do? I bet I was so close to the answer on this. Yeah, I knew I was so close. I just took another guess of it. What should I do over here to get this next answer? Any guesses on what I should change over here on the right to get the next answer? It says what percent of IQs are between 116 and 128. So how would I use this app right here where I have the mean and standard deviation already entered in? How would I use it to figure out what percent are between 116 and 128? Press between. And then we go to between and we just enter in the numbers. And that's actually where the first standard deviation is. And then there's that. And I had a good enough guess that it gave it to me. I mean, I was right there on the number. It is 11.9. And the reason I also knew this is if you know the empirical rule, between 116 and 132 is 13.5. So for those who know the empirical rule really well, you would know 34, 13.5, 2.35, and 0.15. I'm just saying that I'm not trying to go over that right now, but I'm just, if you're like, yeah, I know that. So then this would be a little bit less than 13.5. Once again, the applet shows you the exact answer. The empirical rule allows me to estimate it. Using the applet, do we always round to 3? You always do what the question says. Good question, Jackie, right there. If the question says round to 3, you can do whatever you want. But the applet will allow you to round within the applet. It just depends on the way my Pearson asked the format. So really good question. We could do another one similar to this. There's a lot of them that have that sort of format that say like use the applet basically. But if you have another one you want us to do, let us know. This is the exact same type of question right here. So I'll mark this. Very common one. People ask about the steer weights. So very, very common one. Good one to do, and I know I get a lot of emails on it. So I know people get stuck on this one. Very common. Would you use this for the question that is representing percentiles? Probably, yeah, maybe. Yeah, we can do the percentile one too. We'll do that one next. We'll do this one maybe a little quickly, and then we'll do that one based on the model. So what are we going to do first? We're going to change the mean and standard deviation. And there you go. Now we're going to go here. We're going to find the value using the percent. And this is basically percentiles. So here's my question to you. The highest 10% is known as the what percentile? The highest 10% is known as the what percentile? The highest 10%, which would be over here on the right side of the curve, is known as the what percentile? The highest 10% is known as the what percentile? The highest 10% is known as the what percentile? Wants us to round to one decimal. The highest 10% is known as the what percentile? What is the highest 10% known as? It's known as the what percentile? Keynotes to have. You should know percentile means area below. Percentile means area below. So the highest 10% is known as the what percentile? The highest 10% is known as the what percentile? Take a guess in the chat. Don't worry about being wrong. The highest 10%. The 90th. You got it. Yeah, definitely. You got it. So you go over here, you put in 90. And you go to below that, and there it is. You could also do highest 10%. That works too. So you could just go here to 10% and view the area above, and there's the same mark, and that's the highest 10%, which is also the 90th percentile. Below is 20%. We go right here and then go below, And you can see the answer right there. And then the middle, 40%. And there it is, these numbers right here. And it wants to 1 decimal place. Unfortunately, it doesn't round to 1 decimal place down there. But we'll just take and round to 1 decimal, going right here. And make sure not to have any blank spaces. It'll probably get mad at me for that. But there, oh, what? I put in the wrong means. Okay, what problem did I do? What was my problem? Wow. Should have looked. How did I do that? I thought I didn't, I thought I did change it. What did Brian do? I didn't do what I told you to do because I didn't change something. I didn't change something. What didn't I change? I might do it so we can do another question here. Didn't change the mean and standard deviation. So there's the right mean and standard deviation. Oh my gosh. And then below 20%. And the top 10%. There we go, that. Boop. There we go. Does that make sense, Jackie? I didn't change the mean and standard deviation, so I didn't give the context of the problem. So if you forget to do that, it doesn't turn out so well. And I think this is sort of the same. We could do this one. We're just kind of doing the same sort of questions. You can see they're very similar. And once again, you want to put in the mean and standard deviation. I'm going to take guesses at these because I love taking guesses. And I want to see if you can take some guesses. So what do you think the answer to the first one is, Jackie? Take random guesses. See how you do. Don't worry about being wrong. But what do you think the answer to the first question is? And then we'll say why. What do you think the answer to the first question is? It says the highest 15%. Now, the reason I ask students to do this is because if you take a guess, and then if you know how to do it, like take a good guess, your guess should be close to the right answer, so you get like a double check. I think I could make a pretty good guess that would be within a point or two of the right answer. So where would be the highest 15%? We actually almost, not quite sure on it. The highest 15% of IQs is probably close to an IQ of what? The highest 15% of IQs is probably close to an IQ of what? What do you think it's close to? The highest 15%. Take any sort of guess. Looking at the curve would actually probably help, so drawing it out. What would it probably be close to? Take any sort of guess. Well, this one has us guessing the IQ. Well, I mean, we can find out the exact answer. And we can do percentiles here on another question. This one says, what is the cutoff for the bounds with the highest IQ for the top 15%? So it's giving the percent. So we'd have to say, find X using the percent. So we're going to enter in the percent, so we can do that. But where do you think the top 15% is? Like, where on this curve is the top 15%? Like, well, 104 is going to be, so if we go where 104 is at, and good guess, 104 is going to be towards about right here. And if you look at the amount of curve over from 104, it's going to be a lot. Does that make sense that there would be a lot of area from 104 over? Probably more than 15%, but good guess. Let me ask you this. What percent of area, this is a really good question, is above 120? This is what I want students to see in good practice. If you went what percent of area is above 120? See if you can answer that right now. What percent of area is above 120? What percent of area is above 120? What percent of area is above 120? Not 70%. So, and we're talking about this area right here. So it's using the empirical rule. So above 120 to greater than 120, going in this direction. Good guesses. What percent of area would that be? What percent of area is above 120? Good guesses. Points in the chat right there. So don't worry about being wrong. Take guesses, say what you're thinking, just speak freely, and I'll say the answer in a moment. But in good guesses. So if 68% is inside, 32% is on the outside, which means 16% here and 16% here, and that's the empirical rule. So make sure to practice the empirical rule and be like, oh, 68, and let me throw you some more points right there. Good, I'll hit buttons. I mean, I just heard a sound effect. I don't know. 68% inside, 32% outside, 16% in either hand. Empirical rule right there. No, that's in good practice. Just then you see it, and you're like, okay, I see it. So with this right here, what you want to do is you want to think, if we know where the top 16% is, because remember we said it's about at 120, the top 15% would be a little to the right of that. So if I were to guess, I'd guess like 121.2. And how's my guess? It's 120.7. Do you see? I was close. I was close-ish. It's a little bit higher than 120. So the answer is 120.7. And you can confirm your answer by saying the top 15% of IQs. Now, the lowest 25, I've got a trick for. And let me think. Let me think of my trick. Okay, I think I know where it's at. I think it's going to be close to 86.7. And that's going to be down here. And we go to below, it's 86.5. Because I know the z-score for it. And this is where the bottom 16% is via the empirical rule. So we could go back to our picture. Remember, we drew this. If this is where the bottom 16% is at, I'll erase some stuff. That's the bottom 16%. So the bottom 25% would have to be above it, somewhere between 80 to 100, which is about how we'd want you to guess, between 80 to 100, because this is the bottom 16. Below 100 is the bottom 50. So you can see the bottom 50 is right there. The bottom 16 is about at 80. So the bottom 25% is 86.5. And then my guess was pretty close because I know a little bit more. The middle 60% is a pretty hard guess, but I think you got this, Jackie. So check this out. Are you ready? Where is the middle 68% of data between? On this graphic, where's the middle 68% of data? So on this graphic, where is the middle 68% of data? Don't worry about being wrong. Where's the middle 68%? Good practice of chapter 5, part 1 right here. Where's the middle 68% of data? Where's the middle 68%? Where's the middle 68%? So see if you can see where the middle 68% is at. Any answers gets points, and I'll say the right answer. Where would the middle 68% of observations be in this curve? Any guess? Give another 15, 20 seconds. Between what and what? The middle 68%. Well, so 110 is about right here. But the empirical rule, and I'll bring up a graphic right here. And Jackie, thank you so much. I'm throwing you 1,000 points. Thank you for all this practice right here. Really good practice. I'm going to bring up two graphics that I would suggest having. I'm going to show you an easy one and an advanced one. This is the advanced one. So that's the advanced one. And then the more easy one right here is going to be the classic 68, 95, 99.7. And they're throwing too many decimals on all these. We have one in our notes, but I can find really pretty ones online. Ooh, this is a pretty one. Okay, copy image. Okay. So, yeah, Jackie, another 1,000 points. You got it. Exactly. So here is the basic numbers on the empirical rule for the 68, 95, 99.7. Jackie, amazing work right there. Wish we had a whole bunch of students here so I could say W in the chat and we get a bunch of W's. But 68 is between plus or minus 1 z-score, and 68, 95, 9.7, so 68, 95, 99.7. And then when you get more advanced, you can break it down, because if you know the numbers, there we go. You can break it down into the 34 components for between 0 and 1. Thank you, Clay, right there. And then you can break it down And we show how to do this in class. If you're wondering, Calc Workshop's got it too, but this is it broken down completely. And earlier I did a question where I said it's a little less than 13.5. So if you've been watching this full office hours, when I saw this, I was like, oh, that's a little less than 13.5 because I knew that area right there. And that's how I was doing those calculations. So when we talk about the middle 68%, the middle 68 is between here and here. The middle 60% would be a little bit tighter. Does that make sense? So do you notice how this is the middle 68? The middle 60 is going to be a little tighter. So what I'm going to do right here for the middle 60 as a guess, I'm just going to go over the question. This is just a guess. I'm just going to go here and say 84 and 116, which is symmetric. It's 16 above and 16 below. And let's check answer. We got it wrong. And then we're going to go here and say the middle 60% and go to between. And you can see we're kind of close. It's 83.2. So we're off by, and then you can just round up because then it's 116.8. So we're off by less than 1. There you go. And once again, I knew the middle 68%, so I went in a little bit because it's the middle 60. Like as you go out from 68, you'd have to go back in to get to the middle 60. And you can see right here, if I go to the middle 68, it's going to expand outward versus the middle 60 is a little inward. Does that make sense how this is the middle? I'll show it in big screen format. But this is the middle 68%, which is between z-scores of -1 and 1. And then this is the middle 60%, which is a little more compact. And that's how I'm able to like make these educated guesses to be like, well, the middle 68 is here. So the middle 60% would be a little more smooshed in. Does that make sense, Clay and Jackie right there? Really good job. A lot of people get stuck on these questions. We might have one more percentile one to do. See if we do another one. I love these questions if you can't tell. So you got the quiz, Jackie. Amazing job. And then we'll do this percentile one. We'll end office hours because we're going to run near the end. Thank you so much. I'm assuming this makes a lot more sense. If you know how to use the applet, you can basically ace a lot of these questions. And so I'm doing these ones right here because, I mean, literally, if you know how to use the applet, they take seconds. I do suggest still drawing it out, though, because when you draw it out, you get a lot more practice on what actually you're doing. So if you're listening to me right now as I take the notes on which question we're about to finish off office hours with, do try drawing it out. Uh-oh. That's just showing that. I thought it was broken. Use the normal model, and then we'll put percentile right here. With percentile, you have to know that percentile means area below the curve. So the 59th percentile would be a little more than the mean. So we're going to take a guess here at, and what's the nearest whole number? A little more than the mean, so we're going to go to 150. 152. The 90th percentile is a z-score of 20% on either side. That's 1.28. This is basically a quarter, a little more than a quarter. It's like 101 more. Oh, did Clay have a question? Oh, Clay got it done too, I think. Nice job, Clay. Now, these are just guesses. If you're wondering how I'm making these guesses, I might have enough time to show. And the IQR is 2/3, basically. 2/3 of that is... Oh, wow, it's 50? Okay. And then you go a little bit over. So it should be, oh, no, it'd be 51. So 102? How do we do? We got one right, and we were just guessing. Okay, let's show you how to get the answers. Please remember, I am just taking guesses right there. So if you're wondering how in the world did I do that, I can show you. It just takes time. You got to see what's in my brain. So here we go on how to do the question. The question wants us to find x using a percent. Now, these are all percentiles, so I'm going to mark below, and I'm going to enter in the mean and the standard deviation for the curve. Notice how they change down below. Now we're going to enter in the 59th percentile and make sure it's area below. Not the best guess I've ever made. Towards the center of the curve is the hardest area to guess. I think I probably got this one in close on this one. Next, we're going to do the 90th percentile, 90% below. A lot closer than I did on the other ones. Like I said, a little easier to guess on the other side of the curve, which means I got the last one correct. To find the IQR, it's the middle 50%. So we go to between and we subtract these two numbers. There is something I know about the IQR, though. I'll show you that in just 1 second in office hours. Q3 minus Q1. And there it is right there. Rounds to 101, but basically 102. So it gave it to me because I was close enough. What I know about the IQR is that the z-score for the IQR is 0.673. And I can show that right here. It's 0.674. And it is 0.674. I gotta rememorize those numbers. So I knew the z-score, and I could have cheated right here and taken 0.674 times 2 times that right there, and that's the length of the IQR. So I could have done that because I know the z-scores, and the z-scores don't change. If you understood that, you really know how to solve this stuff, because I did that super quick at the end. The important thing you should be knowing right now is how to get these numbers right here using the applet and knowing what you're seeing. The z-score tells you how many standard deviations above or below the mean something is, so you could find the bottom 25% and the top 25% and subtract their values. So a test question could, a really hard one, give you this value and expect you to take this value of a z-score of 0.647, multiply it by the standard deviation, and then go above the mean that much. And that is where the 75th percentile is, right over here on the curve. It'd be right over, I can't get it on the screen at the same time, but it'd be right over here on the curve is where the top 25% is at. We could ask you to find the IQR and things like that. And we'll go to the top 25%, which is the 75th percentile. We'll put back in the context of the curve. And there you go. There is the number, more calculated with decimals. We could round it right here, but this just carries a lot more decimals for you. And these questions are difficult. Do not wait to start chapter 5 till the end. If you're watching this office hours and you're confused, come to the next office hours. Be like, you know what? I'm going to come to the next office hours and ask a bunch of questions. But don't worry. If you're watching this in the future, that's awesome. We just appreciate it. And let us know when you have questions. Chapter 5 is a tough one. Bye for now, everyone. Bye.
Hey Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam.
No!